Hi everyone. Let's look at an example where instead of numbers we have a function or an expression which we are being asked to simplify. So here I have square root of 2x squared plus 4x plus 2. First of all, I'm going to try and um, see if there are ways in which I can rewrite this function. The first thing I notice is that all of these numbers are even, which means I can factor out a 2. When I factor out a 2, I get x squared plus 2x plus 1, which sort of rings the bell that, wait, this might be a perfect square because it follows the 2 times 1 times x plus 1 squared, which we know from our factoring um, lessons that this is actually a perfect square. So this is 2 times x plus 1 squared, and the radical can be replaced by 1 half, which becomes 2 to the 1 half, and x plus 1 squared to the 1 half, which becomes 2 to the 1 half, and x plus 1 2 times 1 half, which is 2 to the 1 half times x plus 1. So this becomes the function in its simplified form. Let's do the same with a few more expressions. Here I have x to the 5, y to the 13, c to the 7 to the 1 half. Right, so that becomes x to the 5 half, y to the 13 halves, c to the 7 halves. Now here, what we want to do is we want to able to um, sort of factor out or remove from the square root what we can. So maybe over here it makes more sense to count pairs, right? So this is x x x x x y y blah 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 till 13 z z z z z z z. So here I can take out two pairs of x. How many pairs of y can I take out? It's actually 6, right? Because 6 times 2 is 12. And how many pairs of z? 3 pairs of z. And what is left inside would be 1x, 1y, 1z. Or an easier way to do that is using fractional exponents. So 13z to the 7 to the 1 half, this becomes x to the 5 halves, y to the 13 halves, and c to the 7 half. Now here, what I do is I do the division and I keep the quotient. 5 over 2 is 2. 13 over 2 is 6. And 7 over 2 is 3. Now the remainders, however, are going to remain in the, because what's remaining here is x to the 1 half, y to the 1 half, c to the 1 half, which is, and that's exactly this expression right here, right? So we take out what we can, and what remains is in the square root. Okay, so same here, this is going to be 2 to the 5, x to the 8, y to the 16 to the 1/3. So 2 to the 5/3, x to the 8/3, y to the 16/3. Now what are the quotients? 5 over 3, the quotient is 1. 8 over 3, the quotient is 2. 16 over 3, the quotient is 5. What about the remainder? 5 over 3, the remainder is 2 over 3. Remainder here is 2, and the remainder here is 1/3. So this can be written as 2x squared y to the 5 times 2 squared x squared y to the 1/3, or 2x squared y to the 5 cube root of 4x squared y. Okay, you can also leave it over here in the previous step in that form, or you can also write it as a cube root. Okay, Now the next goal now is to understand how the algebra of these things work. So which has really been our so the sequence of what we do is we learn something new and then we see how we can add or subtract them, combine them in different ways, multiply them, divide them, etc. So here, adding and subtracting, it's based on the like terms, right? For example, when you had like polynomials, what we said was these are like terms, right? And these are like terms, so they combine. So the 2 plus 3 gives me 5x, and 1 minus 2 gives me negative 1x squared. It's going to be the exact same here. So for example here, if I have 3 root 2 minus root 5 plus 7 root 2 plus 3 root 5, in this case the like terms are going to be the ones which have root 2. So these are like terms. And the other like term is going to be the root 5 one. So we combine the root 2 one, right? 3 plus 7 is 10 root 2, and the negative root 5 plus 3 is 2 root 5. So the theory here is, like in polynomials, you have x and x squared as being different things and that they can only combine with other things that look like them. In the radical case, you can only combine things that are the same radical of the same number. So they are like root 2 or root 3. So a root 2 term will not combine with a root 3 term when you are adding or subtracting. So the steps that you would want to follow is factor and write in the simplest form, and then you combine the like terms. So factoring is important. For example, here, just by looking at root 18 and root 8, I cannot say that these are not like terms, right? So I have to factor 18. What is 18? 18 is 2 times 3 squared. So this is 7 square root of 2 times 3 squared, and 8 is 2 cubed. 5 cube root of 8, 2 cubed. So here there's a pair of 3 and there's a pair of 2. So 7 times 3 root 2 plus 5 times 2 root 2. Now suddenly after factoring, they become like. Okay, that's why the factoring is important, because right at the beginning it may not be clear that they are actually like terms. So this is 21 root 2 plus 10 root 2 giving me 31 root 2. Let's look at the next one. That's 4 square root of 3 cubed x minus 8. 12 is 2 times, or 2 squared times 3x. So 1 3 factors out, 1 2 factors out. So this is going to be 12 root 3x minus 8 times 2, 16 root 3x. Now once again, if you look at the square root terms, they are the same. Therefore, they are like terms. So it doesn't just have to be numbers, right? As long as what is inside the square root is the same exact thing, they are like terms. So 12 minus 16 is negative 4 of these square root of 3x's. Now here we have 2 cube root of 16 is 2 to the power 4. Cube root of 54 is 3 cubed times 2, which is 27 times 2. Now from 4 copies of 2, I can pull out 1 copy. So 2 times 2 is 4, and I'm left with 1 2 inside the cube root. 3 copies of 3, I pull out a 3, so I'm left with 1 copy of 2 in the cube root. Again, 4 minus 12 is negative 8 cube root of 2. So again, numbers that don't look like they will be like terms may end up becoming like terms. So in order to make sure you don't miss out on anything, what you want to do is you want to make sure that you factor it. Okay. Now here it's 5xy to the 2, but this is a cube root, right? But there are no 3 copies of x and there are no 3 copies of y, so this cannot be simplified. So it's as it is. Now here, however, cube root of x to the 4 means there's one that, or let me rewrite this first as 2 cubed x to the 4 y to the 5. So there's a copy of 2 that goes out, a copy of x and a copy of y. So I have 2xy. I'm left with one copy of 2. Oh, sorry. I'm left with no copies of 2. It's one copy of x and 2 copies of y. So xy squared. So this is 5 cube root of xy squared. Now once again, I have this like term. So here now the combining them is going to look like factoring. Because in this case, the 5 and the 2xy are not things that combine. Right? In the previous example, we had 4 and negative 12. So 4 minus 12 gave me one single term, which is negative 8. But 5 plus 2xy cannot be combined or rewritten in a simpler form. So it just remains as 5 plus 2xy. Okay, so that's about addition, subtraction. Just remember that things may not look like they might combine, but as long as you factor them, whatever can combine will come out to have to contain like terms. Okay, that's it in this video. The next thing that we need to talk about is dividing radical expressions, and that's pretty much it. That would be the end of this week's material. Thank you.